Um, Hello, everyone. Thanks for your interest in this presentation. My name is Xingyu. I'm currently a postdoc at the Computer Science Department, University of Liverpool. Today, I will present our first abstract paper on detecting operational adversarial examples for reliable deep learning, and Wei, Sven, Xiaowei are my co-authors. Okay, so deep learning model is known to have robotics issues. Although there are many different definitions of deep learning robotics in the literature in different contexts, they all share the same intuitive meaning that we want the output of the deep learning model is invariant to small perturbations on the input, and a perturbed input is called a adversarial example if it leads to a different result compared to the output of the original input. All existing verification and validation methods for deep learning robotics are essentially about detecting adversarial examples. One of the important criteria on evaluating a given V and V method is to see how natural or how realistic the detected adversarial examples are. Yes, this is making a good sense because we don't want to waste our time and money on detecting those unrealistic adversarial examples that you probably will never see in the real life operation. But is this concept of natural, realistic adversarial examples good enough, especially for the delivered reliability of perceived by the end users? To answer this question, let's first look at a lesson learned from traditional software. In this paper 4, Adams actually show us that it would take 5,000 years of execution based on the end user's day-to-day operation to trigger 1/3 of the bugs in the software system. So clearly, detecting those 5,000 years bugs is unwise. Instead, we want to detect bugs that have higher chance to be executed by the users. And the user's behavior can be modeled by operational profile, and we say OP for short in this presentation, which is essentially a notion used in the software engineering community. The OP is actually a probability distribution defined over the whole input space, and it returns the probability of an input being executed by the end user. So for deep learning, the lesson learned here is we want to detect adversarial examples on the high density area of the OP, for which we name it in the paper that operational adversarial examples. We believe there should be the trend that we want to do better than detecting natural, realistic adversarial examples. We need to detect operational adversarial examples. And operational adversarial example is a more stringent and a more useful concept for the reliability, because a operational adversarial example has to be realistic, but not the other way around. So far, we didn't see any dedicated technique for detecting operational adversarial example that motivates our research. Right. So the research objective is to design a new testing method for deep learning software, mainly focusing on detecting operational adversarial examples. Specifically, we need to integrate and optimize the following 3 pieces of information. First, for sure, we need to consider the operational profile. Second, we need to consider the naturalness, because in practice, we can never learn a perfect OP. So for some local areas in the input space, we still need the naturalness as an approximation for the local OP. And finally, to detect as many adversarial examples as possible in the given budget, we also need to consider the gradient of loss of the deep learning model in the input space. To achieve the objectives mentioned above, we proposed a 5-step loop in which each step represents a research question. That is, first, we want to learn the OP efficiently from data or from simulation. Then we need to find some Cs for our test cases so that the Cs are from the high density area on the OP, and at the same time, they are also from the buggy area in the loss space. Then given a set of Cs, we try to search for adversarial examples around the seed, considering both the gradient of loss and the local operational profile. And once we detect a set of operational adversarial examples, we need to retrain the deep learning model based on those detected bugs. And finally, we need to assess the deep learning reliability and see if the targeted reliability has been satisfied or not. Then we can decide if we want to do another round of the loop or not. For sure, this is a ongoing research, and we are now developing all those 5 steps in the loop. For now, we have some preliminary results for the step 5. You may find a model in that link. And also, for a better communication in the regulation and certification, eventually all results, assumptions, claims generated from the loop will be presented in assurance cases. And we also have some results here. You can see those links. Okay, so that's my presentation today. Thanks for your time. If you have any questions, please feel free to drop me emails. Thank you.